So we only have a few more lessons of ratios. So now we're on lesson 23, which focuses on problem solving using rates, unit rates, and conversions, just like we've been doing for several of our previous lessons. Our I can statement is I can solve constant rate work problems by calculating and comparing unit rates. So what do we notice here? Well, I'm going to be finding those unit rates again, where one of my numbers in my fraction, mainly my denominator, is a 1. The top number tells me how fast or how long I'm doing something, or how much something costs. So here we're going to be calculating, so we're going to be solving, we're going to be comparing. So we might have two unit rates, and we need to compare them, or discuss how they're related or how they're different. Also notice this is a rate work problem, so that's going to be our new term. We've done unit rates with price. We've done unit rates with distance. Remember, in each of these, our distance was on the top. And what was on the bottom for distance? Well, on the bottom, that was time. So remember, it was like miles per hour. Price, what does that mean? Well, price, remember, or quantity, or the amount of something we're buying, that was always my number on the bottom, my denominator. How much it cost was always my numerator. So numerator was the cost, the denominator was the number. In distance, this was always my speed, and on the bottom was always time. So let's go to our first problem. Suppose that on a Saturday morning you can cut 3 lawns in 5 hours, and your friends can cut 5 lawns in 8 hours. Your friend claims he is working faster than you. Who is cutting lawns at a faster rate, and how do you find out? Well, the first thing we need to know is this. We need to compare them at the same rate. How much can they cut in 1 hour? I can't compare 8 hours to 5 hours. If I could, I can easily just say, well, he cuts 5 lawns in 8 hours, so he cuts more. But this person is working in 5 hours, so they're naturally going to cut less. So what we need to do first is we need to find out them at the same rate. We need to find their unit rate. So my very first thing is I'm going to fill in my ratios, 3 to 5 and 5 to 8. And what do I need to do next? Well, what I need to do next is I need to put those labels on. If I don't have those labels, it's going to get confusing. So now what do I need to do? Well, I now need to find the unit rate. So let's go to our next slide. So it's the same thing, but now I need to set this up as my unit rate. So I'm looking for 1 hour and 1 hour. So I'm going to ask myself this. How do I get from 8 to 1? Well, I'm going to divide by 8. Whatever I do to that left side, I have to do to that right side. So I'm going to have this. 5 divided by 8. Make sure you send the problem up in the correct order. It's not 8 divided by 5. Goes in 0 times. I bring that decimal straight up. This is going to go in 6 times. 48. This is going to go in 2 times. 16 with the 4 left over. Add that 0 since I ran out. So this is going to be 0.265 hours. Remember, normally with fractions, we don't have this. Normally in fractions, we don't have a decimal. However, since it's being used as a rate, it is okay. I'm going to do the same thing here. So now let's look. What do I need to do to get 5 to become 1? Well, I divide by 5. So I'm going to do the same thing here. I'm going to divide by 5. So now I'm going to do the same thing. 3 divided by 5. Going to add that decimal, goes in, bring the decimal straight up, 0.6 lawns. So now I can ask myself, who can cut more in 1 hour? Who is cutting faster? Well, here, this person is only cutting 0.6, this person is cutting 0.625, so this person is going to be cutting them at a slightly faster rate. Let's try this problem. You own a restaurant. You want to do some advertising, so you hire 2 students to deliver takeout menus around town. One student, Darla, delivers 350 menus in 2 hours, and another student, Drew, delivers 510 menus in 3 hours. You promise a $20 bonus to the fastest worker. Notice it's not the worker who works the longest, it's my fastest. So who is delivering more per hour? If it was just my longest worker, well then that'd be easy for Darla, or easy for Drew. They could just pass out 2 flyers and then wait till the end of the day, wait 8 hours. But we're looking for the person who delivers the most per hour. So that's going to be the same thing. I need to compare that at the same rate. How much to deliver in 1 hour? So I'm going to start out with my unit ratio, or I'm sorry, just my regular ratio. So Darla is 350 for 2 hours. Drew is 510 for 3. Again, don't forget, I need those labels. Okay? So now, just so we can see a little nicer, there's my setup. So let's go to our next one. I'm going to be finding my unit rate. This is going to be saying I need to find who delivers most in 1 hour. So again, I'm finding the unit rate, meaning that denominator is 1. So I'm going to ask myself, how do I get from 3 to 1? Well, I divide by 3. So I need to do the same thing to my, what? Numerator. So here, oops, that's divided by 310. So here I'm going to do 510 divided by 3. It goes in once. So I'm going to be doing 170 menus. We need to do the same thing here. How to get from 2 to 1? Well, I divided by 2. So I'm going to do the same thing here. So it's going to be 350 divided by 2. So it's going to be 175 menus. If you're not sure about this way of long dividing, you can always go the whole entire way and you'll notice it'll be the same. So let's look. Who's going to get that $20 bonus? Who works faster? Well, if I'm going to pay someone, I'm going to want to pay them who's working faster. So I have 175 menus versus 170 menus, both delivered in 1 hour. So I'm going to be giving it to this person, to Darla, since she's working slightly faster. Okay, let's look at this next example. Which runs faster? A cheetah that can run 60 feet in 4 seconds, or a gazelle that can run 100 feet in 8 seconds? Well, I'm going to start up like this. I'm going to just find my ratios first that they're giving me in the problem. So here I see that 60 and 4 is right here with their labels. That 108 is right here. So I'm going to ask myself, what do I do next? Well, how do I get from 4 to 1? How do I get from 8 to 1? Well, since I'm working with ratios, I always want that bottom number to be 1. So I'm going to divide by 4, which means I need to do the same thing to my top number, divide by 4. So 60 divided by 4 goes in 1 time. So a cheetah is going to run 15 feet per second. So now let's look at my gazelle. Well, I'm going to ask myself the same thing. How do I get from 8 to 1? Well, easy. I divide by 8. So I'm going to do the same thing here. How do I get from 8 to 1? Well, I divide by 8. So what do? 100 divided by 8 goes in 1 time. Goes in 2. I'm going to have a remainder of 4. And then I'd bring down that 0. Right here. And then I'm going to be left with 12.5. So let's look. Who runs faster? 15 feet per second or 12.5 feet per second? Well, naturally my cheetah is going to be running faster. The only hope my gazelle has of not being eaten is that they can turn much sharper than a cheetah. They can also run longer. Okay. Okay, so now let's look. What if the units of time are not the same in the two rates? So for example, here I have seconds and seconds. But what if instead of seconds and seconds I had seconds for one ratio and the other ratio was hours? What do I know? Well, I cannot compare the rates. So what does this mean for the rate units, or my unit rate? It means I need to convert them. I'm going to need to change hours into seconds like we practiced last week. or hours, I'm sorry, not hours into seconds, hours into 60 minutes. And then compare that seconds into hours. So this way, I'm left with minutes to minutes. Or I can convert them all to hours, I convert them all to seconds. But either way, I need to make it so they're the same unit. So the secretary in the main office can type 225 words in 3 minutes, while the computer teacher can type 105 words in 90 seconds. Who types at the faster rate? What did my previous page say about units? Well, it said this: I can't compare minutes and seconds. So what do I need to do? They need to be the same. We need to convert. So I need to change my seconds to minutes. So let's start here. So I'm first going to start by writing my ratio out. 225 words. So I'm just going to put a W over 3 minutes. And then I'm going to write my other ratio, 105 words per 90 seconds. Well, I can't compare minutes to seconds, so what am I going to do? Well, I'm going to change my seconds to minutes. So let's work here. How do I do that? Well, I know there's 60 seconds in 1 minute. So now I'm ready to go. I'm going to have 105 words. My seconds cross out. So it's 105 times 60 equals 6,300 words per 90 minutes. So you'll notice I'm only left with words and minutes, so now I can compare. But I have a problem. I need to simplify. So how am I going to do that? Well, I'm going to cross those out, and I'm ready to go. 630 divided by 9, which is 70. So this is going to equal 70 words per 1 minute. What do I do? Well, I need to make an equivalent fraction. So this is going to be 225 divided by 3, which is 75 words per 1 minute. So who types faster? Well, according to this problem, it is my secretary at the school. She types 5 words per minute faster. So let's look at it from another way. What if I change the unit to seconds instead of minutes? Here I'm comparing minutes. What if I change it to seconds? So I'm going to do the same thing. 225 words per 3 minutes. Just start out with the same ratio. 105 words per 90 seconds. I'm going to find my unit rate. So this is going to be what? Per 1 second. So I have 105 divided by 90. It's going to go in 1 time. Oops, I'm sorry, not 1 time. In that spot, 1 time here. So I'm going to get 15. I add that decimal. I'm going to add a 0 to bring down. This is going to go in 1 time. 60. Add that 0, bring down. So it's going to go in what? 6 times. And look, I have a repeating decimal. So I'm just going to put that line over, or I can round, either one. I think I'm going to round it though to 7. Remember, this was a 6 right here, so it would round that previous number 1 up. So your computer teacher types 1.17 words every second. What about this? Well, this person can't compare minutes to seconds, so what do I need to do? I need to change it to seconds. So this is going to be what? 1 minute over 60 seconds. My minutes cross out. I'm left with 225 words per 180 seconds. So now I'm going to simplify that. So I have a 1 second. So I need to do what? I need to divide my numerator with my denominator. So 225 divided by 180. I just know it's going to turn to a decimal by looking at it, so I'm just going to get ready. It's going to go in what? 2 times. So how fast can the secretary write? She can write 100 or 1.25 words per 1 second, which we see is still faster. So what does this mean? It means that if you convert to minutes or seconds, you'll still always get the same answer of who is typing faster. So if it's not asking you for a specific unit, you can do seconds or minutes or even hours. You'll still always get the same person typing fastest. So here's our lesson summary. Rate problems, including constant rate problems, always countermeasure something happening per unit of time. The time is always in the denominator. So just like speed or distance, time is always your denominator. Sometimes the units of time in the denominator of the rates being compared are not the same. So like the one we just did, they're not the same. So we must convert and make sure they are the same before we go on. Alright, here is your assignment. What you're going to do is you're going to log on to Socrative. There are going to be 5 problems. I want you to solve those 5 problems. Then, when you're done with that, you're going to log on to Khan Academy. On Khan Academy, you're going to do 2 lessons. Then when you're done with that, you may play math games. Alright, good luck.